Oh. That's awesome. Take a look at your first two answers, and you'll notice that the coefficient here, this part of the number is called the coefficient, or it's also called the mantissa. Okay, your choice, what you want to call it. I think coefficient's probably more familiar to most of us. The coefficient in A is the same as the coefficient in B. And what do you notice about the pHs? They have the same decimal places, and that hits home the fact that those are your significant figures, right? Because you have 2 sig figs and you have 2 sig figs because the decimals correspond to the coefficient. Yes? So, yes, pH can be negative. It can be less than 0. And yes, pH can be greater than 14. Okay, and those are just a couple examples to prove to you that yes, they can go beyond the normal range that we are used to seeing. Okay? All right, you're going to write for me the auto-ionization of water, the shorthand method, and the reality. See if you remember. Do those look like your reactants? 1 water for the shorthand method, 2 waters for the reality. Yeah? Is that looking good? All right. In our reality equation, water is acting as a what kind of acid? Bronsted. What's the other name? Lowry acid, and it's acting as a Bronsted Lowry base. Therefore, water is, fill in that word, see if you can remember how to spell it. So what does amphi mean? Amphi means both. Protic refers to protons. So it can both accept and donate protons. Could you please write two KEQ expressions for the autoionization of water? Yes. It's okay? Yes. Because water is the solvent. It's a liquid, it does not have a concentration. Yes, yes, because water can't dilute itself. Do you know what I mean? Yeah, yeah, yeah. You could also write it as two, the other way to write this one here is you could write 2H2O in equilibrium with H3O plus and OH minus. Yeah, yeah. Which makes it a little clearer that there's only one liquid. All right. And do you remember what we call this KEQ value? We don't call it KEQ, we call it KW. And if you ever forget that it is 1.0 times 10 to the negative 14, let's go look at your data pages. On page 5, so your pink sheets, get your pink sheets out. Pink sheets. Page 5. Pink sheet, page 5. If you don't have a pink sheet, there are some extras up there. And what do you see here down at the bottom? We got water, and its dissociation constant is 1.0 times 10 to the negative 14. That means that Kw is also the Ka for water. Yes, Kw is also the acid constant for water. Is good? Okay. Now, guess what? You have one equation here that has 3 variables in it. If I give you 2 of the variables, you can always solve for the third. So could you please here we go. We've got H3O plus is equal to 3.0 times 10 to the negative 3. Kw is equal to H3O plus times OH minus. Now, what I'm showing you here is I'm showing you all the work that you should show when you write the pH and pOH and H plus and OH minus quiz. Okay? If you're in the midst of another question, you might get a little bit more lax in what you show. Okay? 1.0 times 10 to the negative 14. So we have those 2 things. Can you solve for OH? Do it. Let's see if I did it right. Do you like that answer? Are you getting the same thing? Yeah? I'm not 100% happy with that answer. What did I forget? I forgot. Units. So anytime you have hydrogen, you can find hydroxide. Anytime you have hydroxide, you can find hydrogen because this formula relates the 2. And did you notice here that this concentration of hydrogen is greater than 1 times 10 to the negative 7? Yes? Yeah? So that means, is this solution acidic, basic, or neutral? I have, let's calculate the pH. If I have 1 times 10 to the negative 7, what is the pH? 7. If I have, let's just make it for sake of ease, let's make it 1 times 10 to the negative 3. Okay, just for the sake of ease. What would the pH be? pH would be 3. Is this solution acidic or basic? It's acidic, right? Because we have a pH lower than 7. Now it's going to be 3 point something because it's 3 times 10 to the minus 3. We could throw it in our calculator if we wanted to. So that means that this solution is acidic. Now, if we have a hydrogen ion concentration greater than, so our hydrogen ion concentration, sorry, I should write it down like that. Concentration of hydrogen is greater than 1. That means that your hydroxide ion concentration is going to be less than, not less than 1, sorry, less than 1.0 or 1 times 10 to the negative 7. Yes? 10 to the negative 7 for hydrogen and hydroxide is neutral at 25 degrees Celsius. Yes. 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 It's not actually 3. I was approximating, so I didn't have to haul out my calculator. It's going to be 3 point something. Uh-huh. That's okay. That's okay. It doesn't really matter. Just go with it. Just be like, when I say that this number here is the power, it kind of is, but it kind of isn't, right? Because what we really have is we have 10 to the concentration of hydrogen, not the pH, would be 10 to the negative 11.27, right? Or 1 times 10 to the negative 11.27. It all works out. It's math magic land, though, as far as I'm concerned. Yeah, so just, yeah. I'm approximately, okay? So our pH here is approximately 3. Not actually 3. It'll be, something else. But yeah. Yes. What's Ka? Ka is the dissociation constant for an acid. So if I had, let's say, for example, if I had acetic acid, CH3, COOH, aqueous, it dissociates into CH3, COO minus, and H plus, yes? So its Ka expression would be products. Oh, I should have left myself more room. Ka is equal to the concentration of CH3, COO minus, times the concentration of H plus over CH3, COOH. Yeah? And the reason water doesn't have a numerator, even though Kw is the Ka for water, is because it doesn't have an actual acid thing. It's just H2O, which is also the solvent. Yeah? Okay, cool. All right. We're feeling okay about that? Okay. pOH, since pH, write down the formula for pH, and then write down the formula for pOH. I would like you to now practice showing all your work. I would like you to now calculate the pH and the pOH for the example on our previous page, which had a hydronium ion concentration of 3 times 10 to the minus 3 and hydroxide of 3.3 times 10 to the minus 12. Try those. Yes, Jude. Yeah. Yeah. No, you're good. You're good. I know. I'm like, oh, you were traumatized, but you're fine. In fact, if you were to write individuals, like you wrote very fine, they're not. Okay. Yeah. Because we actually added some more things where that's and that will bump that up. Okay, so it's around 3 because 3 would be this concentration of 1 times 10 to the minus 3, right? But if we look here, you can see it's close to 3, but it's not actually 3. Yeah? If we really did the calculation, it would be 2. Yeah? Yeah. Okay, I've had a couple of questions, and I wanted to go over them just to make sure we're good. The first question was, how can we have this concentration of hydronium and a different concentration of hydroxide? Like, what's going on? How did this happen? And what has happened is we had some water and we added some acid to it, maybe some HCl, okay? And the Cl would then be a spectator ion, and it would shift our equilibrium. If we added some acid, it would shift our equilibrium to the left, but we would still have more hydronium than hydroxide. Yes? But we won't always mention that we did that. We'll just tell you the hydronium ion concentration, and you can be like, oh, it's acidic. They must have added an acid. Or if it's basic, you go, oh, it's basic. They must have added a base. Check to see if you got your sig figs right. Okay. And do you remember that back on the previous page I said the pH of this solution was approximately 3, right? But it wasn't exactly 3 because it wasn't 1 times 10 to the minus 3. You can see it's close to 3, but it's not actually 3. Did you get 11.48 for the pOH? Yes.
Yes.
What happens if you add 2.52 to 11.48? You get 14. Yes? So if you multiply hydrogen concentration times hydroxide concentration, you get 1 times 10 to the negative 14. Yes? If you add the pH and the pOH, you get 14. So this is what you should show for your work. Do we need to do this? No, we're good? Okay, moving right along. Okay, pH, pOH, and pKw. There's a pKw. Can you guess what pKw stands for? What the formula is for pKw? It's the negative log of Kw. Right? So we have pH is the negative log of H, pOH is the negative log of OH, pKw is the negative log of Kw, and P misspence is the negative log of misspence. Yes? Okay. So here is our relationship. What if we took the negative log of everything? Yes? What if we took the negative log of everything? Hi. Oh yeah, absolutely. Yeah, no problem. So what do you get if you have negative log of 1.0 times 10 to the minus 10? What do you get? Negative log of 1.0 times 10 to the minus 10. This is not hard. You guys have done just a bunch of these. What is it? 14. God bless you. Okay. I'm taking the negative log of both sides. Okay? Now, if I take the negative log of hydrogen times hydroxide, do you guys remember what it is if you take the negative log, or if you take the, let's not even put the negative there. If you have the log of A times B, what is that the same as? Log A plus log B. If you haven't done your math course yet and you don't know this, that's fine. You don't need to know how to derive it. But this is how it comes across. So if we have the negative log of H plus times OH minus, what that means is we're going to have the negative log of H plus the negative log of OH. Yes? And what that means, what is the negative log of H? That's the pH, right? And what's the negative log of OH? The pOH. So pH plus pOH gives us 14. Are you trying to pronounce it? Okay. Okay, this just goes through the whole thing. We're going to skip to our next page because we just went through the math. So we're now on page 78, halfway down the page. Hebden has a lovely little conversion chart. Yes? P stands for the power of 10. So it's the power of 10 of the hydrogen ion, power of 10 of the hydroxide ion, power of 10 of the Kw. So power of 10 of Kw is 14. That's not, I don't think, what it really stands for, but that's what I say it stands for. I don't know for sure what it really stands for. Feel free to look it up. You can tell me if I'm wrong. Okay. If you have no problem remembering these relationships, you're good to go. If you do have problem remembering these relationships, this is a handy little chart that you can use to help you remember. So at the top, we have hydronium and hydroxide. Yes? How do we relate hydronium and hydroxide? We use Kw. Oops. Down at the bottom, we have pH and we have pOH. How do we relate pH and pOH? pKw, right? pH and pOH relate by pKw, and if you prefer, you can write this as pH plus pOH equals 14. And I'm going to put 14.00 because that takes care of the 1.0, 2 sig figs times 10 to the negative 14. Good is good? Now, you know also how to go from hydronium to pH, right? Take the negative log. You know how to go from hydroxide to pOH, take the negative log. Do you know how to go backwards? What if we wanted to go this way? So if I gave you, let's do whole numbers first. If I gave you a pH is equal to 5.00, what is the concentration of hydrogen ion? Or actually, let's not even make it 5.00, let's just make it 5. If the pH is 5, what is hydrogen equal to? Yeah, it's equal to 10 to the negative 5 molar, or 1 times 10 to the negative 5 molar. So what did we do to get from here to here? We took what number? We took the number 10, and what power did we raise it to? The negative pH. Yes, yes, our pH was 5. This right here is the negative pH, yes? So hydrogen ion concentration is equal to 10 to the negative pH. Yes? How would you find hydroxide given pOH? It's 10 to the negative pOH. Now, how can you remember that? You can be like, okay, I know that pH is the negative log. So the first thing I do is I take the log and then I change the sign. Yes? So I need to go backwards. So going from hydrogen to pH, take the log and change the sign. Going backwards, we're going to change the sign, then take the opposite of the log, the anti-log. When you do 10 to the whatever, that's called the anti-log. So you can either just use 10 to the whatever, or you can call it antilog. So 10 to the x is antilog of x. That's what the function is called, but it's easier to write it as 10 to the x, okay? So I don't tend to write hydrogen is equal to antilog of negative pH, but you could. I tend to write hydrogen is equal to 10 to the negative pH. So how do you go backwards from log? You change the sign, and then you do the opposite of logging, so you take 10 to the power of whatever you have. And that's what's described here. When we find pH, we log it, and then we change the sign. When we go backwards, we have to change the sign and then anti-log it. So here's our formula written in the format with anti-log. Here's the formula written normally, okay? Now we also have to take into account sig figs. Can't forget the sig figs. pH is 4.0. How many sig figs in pH 4.0? 1, right? Because we only count after the decimal. One sig fig. So when we have our 10 to the negative 4, we need to put a coefficient in front of that. We're just going to write 1 times 10 to the negative 4 because this has 1 sig fig. Yes? So really, once you kind of get a feel for the formulas, the only tricky part is remembering the sig figs, okay? So only digits after the decimal in pH are significant, therefore our answer has to have 1 sig fig. I would like you to try this question. Can you give the answer to the correct sig figs? If pH is negative 1.00, hydrogen ion concentration is 10 to the negative pH, so that's the negative of negative 1.00, which is 10 to the negative 1, no, positive 1, sorry, which is just 10. Please write that with correct sig figs. There are 2 ways of writing it. What's one way you could write it? You could write 10 dot molar. What's another way of writing it? 1.0 times 10 to the 1 molar. Either of those are okay. I would like you to punch this into your calculator, this next one. I've written the formula the other way. So punch that in, just so you're familiar with the term anti-log. And you should get, see if we get it correct, 4.7863 times 10 to the negative 8. Is that what you guys got? that what you guys got? Oh, I haven't put it to sig figs yet. Is that the number that you got? That is the number that we got. Now, how many sig figs should we have? We should have 3 sig figs because after in pH, it's only after the decimal, so 3 sig figs. So this is then going to round to 4.78 times 10 to the negative 8. Yes. Oh, okay. So there's a couple of ways of fixing that. The first way is to just multiply by 1,000. Okay, but there should be a mode that lets you go into scientific notation and other notation. So you can find that mode by looking up chart and then ELW516XG and look up the manual. Or you can say, I'm going to just multiply by 1,000. And if you make it, you just have to remember that one by 4. Yeah, that's the fast way of doing it, but find your mode. And what is me, I actually wrote. Here. FSC. You don't have FSC book? Okay, anyway, you can look it up. If you have an FSC button, you just push it, push it, push it, and it changes it. Anyone else having a problem with their calculator cutting off their number? Yep. But you hit the whole thing, so you're good? You were right here? Okay, cool. Okay. There we go. There's our chart with everything in it. Now, you can use kW is equal to 1.0 times 10 to the negative 14 if you need only 2 sig figs. That means if your other numbers you're working with have only 2 sig figs, use this one. Yes? If you're working with 3 sig figs, use those numbers so you don't decrease the number of sig figs. Yes? Yeah. Now, let's just see if your AP data sheets give you any particular values. And if that's the case, we will use those values. Okay. It just gives you 14, so it really doesn't care what you do. Okay, it's like good enough because you know sig figs. So you can just throw zeros on there willy-nilly. Okay. So the nice thing is actually they give you the formula. Oh, and they do give you 1.0. So I would just go for 2 sig figs on the 14.00 on the AP exam because we have 2 sig figs here. So I would go with 14.00. So you have 2 sig figs there. Okay. So isn't that nice? They give you kW. They tell you the pH formula, the pOH formula. They tell you the 14 is pH plus pOH. Your regular exam will not be given to you. You just need to know them. But I don't think they're that hard to remember. Okay, so hopefully you can just remember them. Give some practice on that. All right, where did we go? There we are. So why don't you guys just do the exercises here for homework? And as always, if you have extra time, what can you work on? Thermodynamics. Yeah.
Guys, everybody go to US Community Church.
Stony Creek, go see the fish. Weather's beautiful for it.